Okay, guys, welcome to the second Math C quiz. I'm very bad at introductions, I don't know how to start. Anyways, speaking of starting, we'll start with the first question of the second CE quiz. Consider the two triangles KLM and RST in the figure below. They gave you the triangles. Now, I believe I have this on the last page of the thing, or I don't have it at all because my thing bugged. Yeah, I don't have it. Okay, so this one I will be doing right now. I solved it, but I just didn't screenshot it. Anyways, you have them. Okay, how do you know if it's an SSS or an AA postulate? First of all, let's get this out of the way. Since they're both triangles, if they're both right triangles, it's not given, but they're both triangles, they're automatically similar. Any two shapes that are like not the same size but are the same shape, they're similar. That's first of all. So this one is out straight away. Now, how do you know if it's AA or SSS? Okay, AA, if there is an angle given, it's most probably AA. But here there isn't an angle given, so it's 100% not AA. If you have measures of sides, it's SSS. If you have sides and no angle, mind you, no angle, then it's SSS. If you have an angle on both angles, sorry, like if you have a right angle here and the right angle here, then that's AA. Let me just get the open board out. Okay, I'll just open it as a desktop. Okay. Okay, now we need to try these. You don't need to like try them. It's not trial and error. It's more just common sense. Okay, so our ratios: KL over RS. Anyways, they are given here, and I believe they're similar for. They're all the same. You don't. They're just common sense. If they don't give you, if you don't know how to find the ratios, they will give them to you. So KL over RS, KL over RS, LM. Okay, they're all the same. So yes, except this one. This one's automatically wrong. I'll explain why. Because LM, RS, LM, RS, different sides. Uh, LM is this and RS is this. They need to be the same side, mind you, same side. Okay, so this is correct. Let me explain why. KL over RS. Now, you don't need to try all of them. You can just try two, since if you try this one and this one, for example, the third one automatically has to be correct. It can't not be correct. Okay, so let's just take LM over ST. LM over ST. Okay, now let's substitute in the values. So KL, which is this side, that's 6, so I'll write it here. 6 over RS, which is 9. Now we set that equal to LM, which is this, and ST, which is this. Okay, so that would be 8 over 12. Now we simplify both, so that's a 1. We simplify both. If they both lead to 2 over 3, then that's the correct one, and the other choices include 3 over 2. If it simplifies into 3 over 2, then that would be the correct choice. But please be mindful of the choices, because if I said RS over KL, I would get 3 over 2, because it would be 9 over 6. Equal to ST over LM, it would be 12 over 8, which is 3 over 2. But here they said KL over RS, so you strictly adhere to what they gave you. You don't like change from it, because that's how you get the right answer. Anyways, you simplify here. You divide this and this by 3, right? Since they're both divisible by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. Now, here you divide by 4, since that's the greatest, greatest common factor between them. Sorry. Or least common multiple. One of them. It's the least common multiple. I am mixing up the grade 5 myths here. Anyways, if you divide by 4, you'll get 2, since 8 divided by 4 is 2. And if you divide by 12, you'll get 3. Since 12 divided by 4 is 3. Okay, so that gives us our answer, which is 2 over 3. And that's KL over RS. and lm over st, not rs over kl. Please, like in the exam, they will do this to you. They did it to me. Luckily, I could spot it. Some people didn't. Okay. Now here, this one. 15 minus 3t. Here I have it on the drive, so I will just go there. Okay, let's just go all the way back up. Now, for this, is there any way, any possible way we can simplify a? No, we can't, because there is nothing to take out. Like here in these questions, they're asking you, can you factor anything? Here you can't. Here there is nothing to factor. Now these you don't have to write them. They didn't ask for the conditions, so these don't write them, but I just wrote them just in case maybe they might have wanted them. Okay, so here there's no factor, so you say it's in simplest form. Okay, and now then you go here. You can see it's 5 minus t and 15 or minus 3t. You can factor. Now here, listen, you can factor this. Like if you do, you take out 3. Okay, you'll get 5 minus t. 5 minus t, that can't be simplified by 5t, can it? So it's still simplest form. That's what they want you to do. They want you to simplify. Now here, it's the same one, but instead of 5 minus t, instead of 5t, it's 5 minus t. So this, when you do factor, you'll get 3, 5 minus t all over 3t. All over 5 minus t, sorry. I wrote it here. Okay, you'll get this. Now, you can cancel 5 minus t in the numerator and 5 minus 3 in the denominator. What you'll get, what this simplifies into is just 3, since it's going to be 3 over 1, which is 3. And for this one, you do need to write the condition. You don't go to this one, you go like the second one, you go to the one from the start. Okay, so what is the condition that would make 5 minus t 0? 5 minus t 0, so yeah, that would be 5, because it's 5 minus t, so it's not 5 plus t. If it was 5 plus t, then that would be negative 5, but we're subtracting. Okay, so t cannot be 5, or else this fraction or this expression will be undefined. Please, when you have written, write t or x or whatever cannot be the value that this would equal 0. So like 5 minus t equals to cannot be 0. This is how you show them in written. You write cannot be, you move this to the other side, it would be minus t, just leave that there, minus t equals to minus 5. You divide by negative 1 in order to like get out the negatives. You'll get t cannot be 5. This is I wrote it equal to. You're supposed to write it not equal to. Okay? No. The third one. You have this right here. This is your equation. Now, how on earth would you simplify this? Because you can't write t plus 2t plus 2. Like you can't factor anything out, and there isn't a remarkable identity for a squared plus b squared or something. There's one for a plus b squared, but there isn't one for a squared plus b squared. So this one cannot be simplified. Okay, so you write no simplification simplest form, like what I did in the one above it, the one that's on part A. Okay, so now we go on to the third question. Okay, here this is extremely basic. I don't think I need to explain a lot on this one. You just cancel out 3t and 18t. This would give you 1 and 6, and here you would cancel out by the 7, which would give you 10 and 8. Then you factor out again. You cancel out again by divide by 2. This would give you 5 and 4. This one we said was 6, so this would be 5 over 24. Of course, t cannot be 0. Why can't t be 0? Now, listen. T can't be, let's just check, it is the right answer. Okay, t can't be 0, because you go back to the start. After you answer, you go back to the start and you check the denominator for any variables that you cancelled out. Because if you leave, for example, say we got 5 over 24 t, then you would not need to write the condition because it would be obvious. Here the condition would not be stated. In some cases it would be, but like in most cases it won't. So don't bother yourself if it has a denominator. No, okay. Where were we? We were here, right? Yeah. Okay, so t cannot be 0, 5 over 24. We got that. That's part A done. Part B. Part B, I'll go back to make my life easier. We'll go on to question 3. Okay, so obviously same thing first. You cancel this is a similar concept. You cancel m minus 4 and m minus 4. You'll get 1 and 1, so this is just 2 and this is 1. And then you cancel out 60n with 105n cubed. You divide by 5, since 60 divided by 12 is 5, and 105 divided by 5 is 21. Okay, but since this n cancelled out, this goes on to be, let's see what they wanted, because this would go on to be, we're on part B, aren't we? Yes, we are. Okay. This would go on to be, this is a square, please be mindful, this isn't a cube, this thing. This is a square. I know it looks like a cube, it's not a cube. Okay. So this would be, there is just 1 multiplied by 21n over 12 times 2. Just don't think because you cancel this and this that 2 is gone. No, because this is also 12 times 2. So this would be 21n over 24. Or, yeah, 21n over 24. And, let's check the conditions, which would, I forgot to simplify. Yeah, okay, then you divide by 7, you divide by 3, you'll get 7 here, and you'll get 8 here, since, 21 divided by 3 is 7. Don't forget the n when you're simplifying again on a written exam. And 24 divided by 3 is 8. Now, you're gonna ask me, why do we have an n here if it's, you can see it in the denominator. Again, you go back to the start. I literally left it in the notes. You go back to the start, you cancelled out n here. Anything you cancel out in the denominator, that's instantly something you write as a condition. And also, we cancelled this out. It doesn't have to be in the denominator. It can even be in the numerator. We cancelled this out. Here it was also in the denominator, but we cancelled it out. So, anything you cancel out, you write it. M minus 4 cannot be 0, so M cannot be 4. Okay, and that's your answer. Now, on to the next question, I believe. Yes. Okay. I have the right answer for this one. Yes, I do, but we're just going to the right answer just in case. Okay, so here, you divide fractions. You guys should know how to divide fractions by now. Quite simple. You do keep change flip. Now, I had originally t over 4 divided by 5t over 9, but I don't like writing it down, so I keep change flips later. So keep, this would be kept, this would be changed from the division to the multiplication, and this was originally 5t, so the 5t was up and the 9 was down, so this would be 5t over 9, but we flipped it. Okay, so we flip, so this would cancel out. T over 4 are multiplied by 5t. The t's cancel out, not the 5. Keep the 5 because this is 1t, so this cancels out. Okay, so right now all you have is 1 over 4 multiplied by 9 over 5. Okay, so 1 times 9 is 9, 4 times 5 is 20. Nothing. This is the simplest form, but you cancelled out again. Anything you cancel out, it goes as a condition. So you write t cannot be 0. That's it. That's question 4 part A done. Now for question 4 part B. This one's long, and I'm gonna like show you how to actually keep changing. So you keep this, then this would be changed into a multiplication sign, and this would go up, and this would go down. Okay. Now I can go over to my notes just so you guys don't get confused. And there is going to be a lot of simplification here, so this is going to be messy. Now 16 over 63 b minus 3 and 36 36 b minus 3 over 40a. Now first you cancel out b minus 3 since that's a common, but keep in mind the original was a square, so when you cancel out you just cross out the square, as it's just going to be exponent 1, because a square is just the same thing repeated. So this would be b minus 3 b minus 3 if I wanted to express it without the square. And then I would just cross one of them out. What's left is just this one. Now you cancel out your normal numbers, 16, and you also cancel out a. Okay. And you cancel out everything. In the end, you'll get 8 over 35b minus 3. Now, why did I cross out? I left this here and I crossed it out on purpose. Why did I cross this out? Now, because you're gonna make something like this probably. I'm not saying all of you, some of you maybe. The reason we did not write this down is it's because it's obvious here. It's obvious that b cannot be 3. Again, I told you, if we leave this in the denominator, then it's obvious that b cannot be b minus 3 cannot be 0. Okay, that's why we leave it. Whereas I think we saw one over here. This one, we don't write this down because we cancelled it out completely. It's not visible in the denominator. Okay, now on to the next question. I believe this is addition. Yep, this is addition. Okay, so for this, for the first one, I won't go to the notes. This is just 1 plus 11 over 4k. So this would be 12 over 4k, but you're not done. You cancel, you simplify. So divide by 4. So this would just be 1k or k over and divide 12 by 4. So this would be 3. So your answer is 3 over k. Okay. Okay. So now the one next to it, the one after this. Again, same thing, but this time there is factoring involved. So this would be let me just go and clip this. Just go to the mouse. Add to current page. Okay. I get out of this. I think I did this before. How did I do? Okay, there we go. My bad. So, what you do here? You get down your fraction. Okay. And you write 6. Oh, it was on the thing. Oh, it's fine. You write down 6y plus 36. Since they're on the same denominator, so it'd be 6y plus 36 over y plus 6. Now, there is a common factor between these two, and it's 6. So what you do, you take out your factors. So you factor. I explained how to factor in the other CE quiz. I will not be explaining it again because it took up most of the quiz's time. And you take it out. So it will be 6 y. This is a bracket. This is just a bracket. Ignore it. Y plus 6. Okay, over y plus 6. Now, before you cancel anything out, you put it in brackets, and then you can cancel. So this would be this, and this would be gone. So your answer is 6. Now, we also write a condition, again, because we cancelled this out, and it's not visible anywhere in the thing. So, this would be in the denominator. So this would be y cannot be negative 6, because y plus 6 cannot be 0, so y cannot be negative 6. And this is your answer. That's it. So now we go to the desktop. Okay, Part C. This will involve a lot of factoring. So I will go to the next page because I did a lot of things here wrong. Okay. So what you do first? You factor this out. You put it in standard form, then you factor. Since this is a quadratic, you use the two brackets and trial and error thing that I explained in the last CE quiz video. Okay, and you try to get the middle number, the middle term in the, or the just the x term, x to the power of 1 term in the quadratic. This would give you 20s. Now, if you go up onto the thing, you'd see that the middle term in the quadratic is 20s. So this factorization is correct, meaning that our answer is 2s plus 5 squared. You can write 2s plus 5, 2s plus 5, but what I did, I simplified into 2s plus 5 squared. Why? Because it's much easier cancelling out squares like this. So you write 2s plus 5 squared. You know when you have the same base, I explained this rule before also on the first CE quiz. This would be A, this would be B. It would equal M A minus B. Now, when you subtract, you'll get 2 minus 3. Okay, so this would be 2s plus 5 to the power of negative 1. Now, what does 2s plus 5 to the power of negative 1 mean? It means you flip it, so you'll put it, you'll take its reciprocal, right? And then you'll put 2s plus 5 to the power of 1. Now, this is the actual true mathematical way. This isn't how I do it though, because it's kind of common sense. You just subtract 2 from the top and 2 from the bottom. Like you subtract 2 from the top, you cancel this out fully, and then you just subtract 1. So this would be 2s to the power of 5 over 1, which is what 2s to the power of 5 of negative 1 is, because 2s plus 5 to the power of negative 1 means 1 over 2s plus 5 to the power of 1. Same with the 2s plus 5 to the power of negative 2, for example. It's just 1 over 2s plus 5 squared. That's how the negative exponents work. Okay, on to question 6. Simply like the simplified. Okay, this is just yap that you don't need. So for the first one, it's quite simple. This and this cancel out. Now, you might be asking yourself, why did we put the result in absolute values? Now, the absolute values are only used in one case, when if it's an even exponent and an even index. An index is the number outside the radical, not the whole number. Like for example, say I wanted to take the cube root of 5, for example. I'd write that 3 up here, right? This 3 is the index. We just took this. So if the index is even, which in this case it is, because it's a square root, so this is to the power of 2, although we don't write it, and the exponent is even, when you take it out, you write and it results in an odd only when it results in an odd exponent. So this would just be 4x plus 5 to the power of 1. 1 is odd, so this resulted in an odd exponent. This is when you write down your absolute values. Okay, this is the only case. Any other case, no absolute values required. Now, this will be important, especially for the ones coming after it, since you know they all this one has absolute value. So, okay, this one. Now, you might be asking yourself, why is it x? This is technically x cubed. You might be asking yourself, why is it not x to the power of 4? Because I have people who asked me this when we started taking this. So first of all, it's negative x to the power of 6. When you have a negative exponent, you can turn the positive, you can turn the negative integer here, or the variable, into the positive variant of it. So instead of negative x, this can be x. It's fine. Only in only in even exponents. Odd exponents, no, they have to strictly be in a positive, or else they are undefined. So if they give you negative 5 to the like this to the power of 3, you can try this on your calculators, by the way. It won't. It will give you math error, I believe, or no, what might have been the opposite. I genuinely don't remember. No, they adhere to the negatives. Sorry, the 1 second. Let's just. Okay, I'm back. So, they have to adhere to the fact of them being positive. Why? Because take x squared, negative x squared, negative x multiplied by negative x, this is an x, multiplied by negative x results in positive x, and negative and negative make a positive. So, now, you would want to ideally uh, make your life easy and just leave it like this. You're not gonna have to write it x to the power of 4, x to the power of 2. Just leave it like this. Just put it positive. Okay, so this would be x to the power of 6. Now, once you take things out of the radical, it would be the exponent over the index, and the index again in this case is 2, so this would be 6 over 2, which is x cubed. Now, you can write it x cubed in absolute values, or you can write it the way they did, which is x squared x to x in absolute value. Now, why you're asking yourself, x cubed is here, this is valid. As I just told you, there has to be an absolute value. Now, if it was like this, then okay, that's perfectly fine. That's an accepted answer, but it's not absolute. When positive, they have to be strictly positive. If you take out odd odd exponents, they have to be strictly positive. They have to, because otherwise their expression is undefined. Okay. And this is according to the book. Now, if you use it on a calculator, it will give you a positive. It will give you an answer. It will give you a negative answer. But I don't know. Just following the books. Anyways, you do the same for this. This becomes positive, so this would be 4x to the power of 4, all in brackets, of course. Then you take it out. It will be 16x squared, and that's your answer. Now on to question 7. Okay, which of the following is the simplest form of 32 is a to the power? Okay, this one, it's not long, but not short at the same time. So what I'm gonna do is I'm gonna snap these two here to each other. Now we're on question 7. Okay, what you do, you split it up into powers of 2, okay, or even powers, sorry, not powers of 2, just even powers. So 32 is 16 times 2, so 4 squared times 2. What you do is you take this 4 squared out. Okay, now 2 multiply, you keep this 2 because just 2 to the power of 1, you can't really take it out. A to the power of 9 becomes a to the power of 8 multiplied by a, just so you can get the a to the power of a, just to simplify a, you take out a to the power of 8 and it will become a to the power of 8 over 4, which is no, 8 over 2, which is 4. So this is your answer right now, 4a4. And now you have b to the power of 14. This is already an even exponent, so you just leave it and you take it out. Now you'll get 7. 7 is an odd exponent, so you write it in the way they love doing, b to the power of 6 multiplied by the absolute value of b. That's the way they said it. Now if they did do b to the power of 7 in absolute values like this, that is fine, that is perfect. But they did not, they left it in this form. So you leave it in the form they wanted you to do. Now the one that is under it, part B, is way simpler. So like that one, in my opinion, that one's the hardest one. So 45 is 9 times 5 or 3 squared times 5. 3 squared times 5 goes out, so it's just as 3. And then 3c cubed root 5. However, they want it in that dumb form, which is 3c squared multiplied by the absolute value of c root 5. That's your answer. Okay, now this one is easy, but it's really long. You guys may get confused. I don't understand why. It's long, I know that. Trust me, I mean, look how long I tried solving it for. It took me like 2 lines. First, what you do, you change this into a fraction. So this, instead of saying 3.6, you say 36 over 10. Okay, multiplied by x squared multiplied by x. So you can take out the x squared. What you do, you simplify 36 first. So 36 is 6 times 6 or 4 times 9. So I prefer you do 4 times 9, since both of them are perfect squares and you can take both of them out. So 4 times 4 is 2 squared and 9 is 3 squared. So you take out 2 squared as 2 and 3 squared as 3. 2 times 3 is 6. So your numerator is 6 for now. And then you also take out the x squared. So it's 6x squared, the root of x, which is what I have here, over the root of 10. Now, you can't have a radical in the denominator. You need it as you need to rationalize. So you multiply by root 10 on up and down. Here I didn't multiply by root 10. I should have made it obvious that on the top you multiply by root 10 too. Okay, now you go 6 root 10 over 10. You keep in mind, do not forget about this. I will bring it in the step after this. I want to focus on the numbers for now. So you divide 6 by, since both of them are divisible by 2, I can divide 6 by 2 and 10 by 2. I'll get 3 over 5. So my answer right now is 3x root 10x over 5, and that is my answer. That's my answer for this. Now, I like leaving them all in the numerator. It's basically the same answer. If you don't want to, you don't like leaving answers on the numerator, they're both accepted. They're both fine. Unwritten, on anything, it's fine. So now we go on to question 8, which has this one's properties are easy. For the parallelogram, the diagonal, the half of the diagonal is equal, can I just change colors, is equal to the second half. So this is equal to this, okay? And so it goes for the other one. This is equal to the other one. So we have y equals 18. They want to find x. X is 18 minus 2, so x is 16. And that's our answer. Okay. On to question 9. So in triangle and rectangle, sorry, KLMN, the measure of angle L equals 3x plus 15. Now, recall that in a rectangle, in a rectangle, all angles are 90 degrees. All angles are right. So 3x plus 15 has to equal 90, since measure of L is basically 90 degrees. They want us to find x. So you take 15 to the other side, and then it will be 3x equals 75, so making x 25, and that's your answer done. Look how quick this quiz is going. So this one, you need to apply the property that the top is half of the bottom. So this is half of this, so this is equal to 16. So this, making this 16. Or what you can do, make your life easier, since both of them are even, you can just do x minus 3, because x minus 3 equal to 8, right? So since half of this is equal to this, so half of 2x minus 6 is x minus 3, making it equal to 8, since this is half of this, so this is double this. You want to, I use that method as it made my life 10 times easier. Let's use the way that the book does it. So this is double this, so 2x minus 6 equals 16. Now you take this to the other side. 2x becomes 22, making x 11. Okay, now only simplify this the bottom half if it's even. So for example, if they give you 2x minus 3, you're gonna have x minus 3 over 2, which you can do, but at that point it's gonna be really long and not that like, easy to do anymore, which kind of defeats the whole purpose. Okay, so let's go on to question 11. This is the same thing for that one. So basically what you do, you can either set 12 over 8 or 8 over 12 equal to y plus 5 over 3y or 3y over 5. So, but you make sure, like if you chose 8 over 12, it has to be y equal to y plus 5 over 3y. It can't be, it just has to be the one that's next to it, under it, whatever it is. So in this case, since it's vertical, it's under it, but they will give it to you in this form. Sorry, let me just make the lines even. They will give it to you in this form. Okay, and they'll tell you like this is 1 and this is 5, for example, and that's a 6 now. Okay, this is 6 and this is x and this is 4.5. I don't know, I'm just giving random numbers here. So you have to make sure it's 1 over 6 equals to x over 4.5 in this case. It's basically vertical, and you go on to the ones that are equal to it. Okay, so you do that. You simplify everything. 8 over 12 simplifies into 2 over 3. So y plus 5 over 3y. You multiply 2 by 3y, making it 6y. And this is 3 multiplied or open brackets y plus 5. Okay, so you distribute. You'll get 3y plus 15 equals to 6y. You take 3y to the other side. 3y will equal 15. Y equals 5. Okay, so now we go on to question, that would be right here, question 12. Okay, same thing. See, they gave it to you in the form I was talking about. So this time, you do this over this equals to this over this. And so was the thing for the other case. You just do the ones that are over each other equal to the one that is equal to, you get what I mean? Like you do this over this or this over this, they work. But the important thing is you set 6 equal to 8 and 3x equal to 10 minus x. That's the important part. And the fraction, of course, they're not actually equal to each other. What you do, then you do all of your things that you're gonna do, and it'll give you x equals 2. So you simplified, you got 8x equals to 20 minus 2x, 10x equals 20, x equals 2. So now there are 2 rules you have to memorize here for the 2 questions after this, no, including this one. So the 1 question after this. So if this is a leg or a side in a right triangle, for example, they want B is a leg or a side. It's going to be the geometric mean of the triangle that it's part of, multiplied by the sum of this one plus this one. So here it's gonna be 9 multiplied by 36. 9 is 3 squared and 36 is 6 squared. You take them both out, it's 3 times 6, making B 18. Now this one's a bit, I'll admit it if you guys want to, it's a bit difficult for some people, I understand, but the one that is coming after this, it's really easy. This one, it looks complicated, it's not that complicated. All you do is h, since it's the altitude, so if it's the altitude, it's going to be, or the height, it doesn't matter, they called it height there, it's altitude, same thing. So h is equal to the geometric mean of this times this, that's it. Now 9 times 4 is 36, so the root of 36 is just 6, and that's your answer. And now we go on to question 15. Now here you have to know the geometric mean theorem for the hypotenuse. It basically states that the altitude and the hypotenuse, so the whole hypotenuse, not just the side of it, is equal to let me just draw on a different color so you guys can understand, is equal to this leg multiplied by this leg. So what you'll get is 50h is equal to 1200. So you cancel a 0 from the 50 and a 0 from the 1200. 5h equals 120. H equals 24. This is mental math at this point, and that's your answer. Okay, and that's pretty much, except one or three questions, something like that. That's all the hard questions gone in geometry. Now, this one, what's the value for x? You have to know that this leg, it's basically what we did. This leg is this leg is the equal to, this is the geometric mean thing we just did. 10 equals radical 5x. Now you do the same thing, so this multiplied by the whole thing, so that would be 10 squared equals to 5x, making x 10 make 100 over 100 is equal to the 5x, so x is 20, and that's your answer. And if you do look at the thing, this is a side, this is a leg, so there is a slight difference, but like it's not that noticeable. Listen, just memorize the rules. It's not that hard. Okay, now this is the Pythagorean theorem. So the Pythagorean theorem states that the hypotenuse is equal to the sum of the legs of the hypotenuse, which is this, the biggest side facing the right triangle, the biggest side facing the right angle, this is the hypotenuse, is equal to this squared multiplied by this squared, and the hypotenuse has to be squared, of course. So what that means, c squared, which is the hypotenuse, equals to a squared plus b squared. Okay, c squared, so c squared, which is the hypotenuse, is radical 164. Radical 164 squared is equal to 8 squared plus b squared. B squared is the one we want to find. So you just have substituted the values that they gave you. So 164, since radical 164 squared is just 164, this cancels out with this, is equal to 64 plus b squared. So 164 minus 64 is 100. 100 is equal to b squared, making b 10, and that's your answer. That's the Pythagorean theorem, pretty much. Now, this is the 45, 45, 90 triangle. The way that the book calls it, I forgot it. It's really weird. Just this is how some textbooks call it, and I find it a better name. Okay, so in a 45, 45, 90 triangle, you have your legs. We'll call them y in this triangle. So it's y, y, and the hypotenuse is y radical 2. Okay. Just memorize it. I have it on the notes. It's right here. Now, note that the s radical 2 is the hypotenuse. Okay, the s radical 2 is the hypotenuse. So like here in my triangle, see, it's the hypotenuse, and here in the exams quizzes triangle, it's the hypotenuse. It's always the hypotenuse, the s radical 2 side. The other two sides are s. In this case, s is denoted as y. So y radical 2 is equal to 24. I have it written here in my notes. Y radical 2 is equal to 24. Okay, so all you do, since you want y alone, you divide by radical 2. This radical 2 and this radical 2 cancel out. You have 24 over radical 2. So now you rationalize. You want to multiply by radical 2 up and down. Okay, so this would just go out to be 2. So this would be 24 radical 2 over 2. Simplify 24 and 2. This would go out to cancel 1. And this would cancel into 12. So your answer is 12 radical 2. And we move on. So here in a 30, 60, 90 triangle, the book calls it a semi-equilateral triangle, and I believe they called it what it was. Even in the quiz they called it 45, 45, 90 triangle, but in the book they have a different name. Irrelevant. Now, in a 30, 60, 90 triangle, the line between the 90-degree angle and the 60-degree angle is denoted as x or s or anything. The hypotenuse, which is facing the thing, the 90-degree angle, is 2x, and the angle between the line between the 30 and the 90-degree angle is x radical 3. Okay, or you could just say the opposite of the 60-degree angle is x radical 3, and the opposite of the 30-degree angle is x. Now, knowing this, don't be tricked. Please don't forget where the lines are, because you could very much easily think, because of this drawing, and this is how it's drawn in most triangles, because this is how some equilateral triangles look. This would be x radical 3, but that's wrong. This is x. This side is just x, because it's the line, it's the leg between the 90 and the 60-degree angles. Okay, so this is x. The 90 and the 30, this is where x radical 3 forms. Okay, and they even gave it to you in the question. QR equals a radical 3. They want a. Now you use this. So 16 is 2x, right? So 2x equals 16. X is 8, and x is a is 8 in this case. Just call it 2a for this. And so then it's this side is just called a radical 3. So this is just 8 radical 3, and they gave you the radical 3, making this answer just simply 8. Or QR in general, the whole line is called 8 radical 3, but they want a sorry, which is just 8. If it could go down, I don't know why it's not. Doesn't show, but it's 8. Okay, this is a theorem. I didn't even solve it myself, because they're gonna bring it up. Please memorize the theorems, but I did not have time to memorize them, and I'll memorize them later. This is more ratios. So basically, what you do here, I've skipped up to question 22. Okay. Listen. So you do this over this is equal to this over this. You simplify everything, you cancel out and you cross multiply, you'll get x equals 9. And they just want the value of x. They don't want IC or BC or anything. They want x. They will ask you sometimes in the exam, what's the value of BC? They won't ask you for x, so please be reading the question. Now, this one, all of you for some reason have been getting this one mixed up or wrong, saying it's 20, saying it's negative 20, saying it's a multitude of different things. This is 10. Let me explain why it's 10. So, they asked you, for what value of k and is the expression all of this a perfect square? Now, recall in perfect squares, they're remarkable identities. They even gave you the perfect square itself, because there are two perfect squares. There is a plus b squared. This is all squared. And there is a minus b squared. Okay. So, 1 second, I will have to mute my mic. Okay, I am back. So, we were here. But I got locked out. So, we were here on the perfect squares. So, as I was saying, perfect squares, they're either a plus b squared. They're both in this question actually. This is the first perfect square, x minus k squared. This is the perfect square remarkable identity. This expands into, I'll use it the way that the question was. So this would be x squared minus 2kx plus k squared. Okay, this is for this one, and for the other one, now it was given the perfect would result for x minus k squared plus 40x would result in a perfect square that can be represented as x plus b squared. So it's given that it's a plus b squared. One second. Okay, so I'm back for the second time. As I was saying, so I talked about the first perfect square. Now we have the second perfect square, which is x plus b squared, or in this case x plus k squared, since it's kind of like given to us with this one. Okay. Now you can expand this into x squared plus 2kx plus k squared. Okay, this is what this expands into. Now you just set it equal to, you set this equal to this, since it gave you, the question gave you that this should result in this. Okay, so we expand as I said, and then you expand for both of them as I literally just said. Oh my god. So x squared minus 2kx plus k squared plus 40x equals to x squared plus 2kx plus k squared. Now you cancel x squared with x squared and k squared with k squared, since you know, like, same signs on opposite hands of the equation, they'll cancel out. Now since this is positive 2kx and this is negative 2kx, they don't cancel out. Instead you bring it to the other side and you add. Okay, you add since this becomes since you know, when you take it to the other side, this becomes positive 2kx, so this becomes 4kx equals into 40x. Now what you do, you divide 40x by 4x and divide 4kx by 4x, which will leave you with k equals 10, and that is your answer to the question. Now I don't know why everyone found this so difficult, because it's really simple if you actually read the question. Personally, I believe you guys just didn't bother reading the question properly the way it was meant to be read, and that's why we got here where no one knows how to solve this. Okay, so now we're on question 23, which is this one. So if this website could load. This one is simple, I won't spend that much time over it. Basically what you do, you set this equal to 0, and you set whatever terms that are separated by brackets or just by multiplication in general, you set them as equal to 0 alone. So you set x equal to 0 and x plus 17 equals to 0. You get what I mean? Like every term, you take this as a term and you take this as a term, both of them equal 0. Okay, and then you substitute in the two values. Now here you have three values, so you take this as a term x, you take this as a term, and you take this as a term. You can find the answer to this problem, like how you properly solve it here. That's I didn't even bother solving it. Just look, x equals to 0, that's kind of given by this, and then x plus 17 equals to 0. X cannot be x can be negative 17. Those are your two answers. Basically, yeah, same thing. So x here is 0, and then x minus 9, so this has to be 9, you know, because 9 minus 9 makes 0, and here this has to be 25, so 25 minus 25 makes 0. Now 5x minus 30 equals to 0. You take the 30 to the other side, it becomes 5x equals 30, making x equals 6. Okay, and then you do the same thing with the 2x plus 46. 2x becomes equals to negative 46. Like if I take this to the other side, it will be like this, and then you divide by 2, which will give you negative 23, and that's your answer for this question. Okay, this one is the sum. Now this one you find the LCD first of all. You find the least common denominator for both of them, which they will give you most of the time. It's this thing, 12y squared, and then you basically multiply in accordance to that. Like you need to multiply, for example, 4y in brackets y negative 1. What can make it 12y squared in brackets y minus negative 1? All it needs is a 3y squared, is a 3y, sorry. So as I did here, you multiply by top and bottom 3y, and then it will be in the 3y in brackets y plus 1, and then 12y squared in brackets y minus 1. This is just saying multiplication, because this is how you're supposed to do it. Then you're supposed to distribute this, and you're supposed to distribute this. That's why you put the brackets there. This is just to show multiplication with the 3y and the y plus 1, since you know this is one term. This isn't, you don't multiply the 3y by the y separately. It's you multiplying it by y plus 1. Please, you guys get this confused for some reason. Anyways, why is my Roomba here at this time? So you multiply and you distribute. You'll end up, you do it for both fractions. As you can see, I wrote it down in my notes. You multiply by 2y negative 1. Again, this file can be found in my drive. And when you multiply, when you do this, you of course multiply top and bottom, as I said. And why are we not? There we go. And then, since this is addition, you keep the denominator common, you don't multiply, and you just add. So you distribute first. You distribute 3y by y plus 1, so this would be 3y squared plus 3y, and this would be 10y minus 10. Now, they want the middle term with the one that has y, so you just add 3y, since you know we distributed this became 3y squared, and 3y, and this became 10y, making this 13y, and they just want the square, which is 13. That's the answer to question 24. Okay, we're almost done. 4 questions left, not bad. This is, I will say that some people don't like this. Okay, so what you do, first you simplify this top. You subtract the fractions from each other. Now I'm not going to explain subtracting fractions, since that's like a KG2 topic, or a grade 2 topic, sorry. You find the denominator. We just did it for addition. It's the same case with subtraction. Anyways, when you do that, you get 1 over 6. Now you apply keep, change, flip. You keep 1 over 6. You change this to a division. You change the division to a multiplication, and you flip 5 over 4, making it 4 over 5. Now 6 and 4 cancel out. This will become 2. This will become 3, making this 2 over 15. And since they want just k, which is the bottom term, 15 is the bottom term, so your answer is 15. Next question. Okay, here, 2 things. First, you need to acknowledge x at the bottom cannot be 0. If they gave you, for example, 5x plus 1, x cannot be I don't know why I did this thing. So this would just be 5x plus 1. I'm giving this as an example, by the way. 5x plus 1 equals, this cannot equal to 0. Keep in mind that this cannot equal 0. Okay, so you take the one to the other side. X cannot be negative 1 over 5, for example. Okay, this isn't meant to be on the denominator. This is meant to be like here in the numerator. Okay, so this is what it is. You just have to make it set to not equal 0. In this case, x is alone, so it's x cannot be 0, or like x on itself cannot be 0. X, you know, get what I mean. Now you just factor this out, or you take this to the other side. Okay, now if you were to factor this out, this would be 2x in brackets x minus 9. Okay, this is factoring. This is by factoring. 2x would be equal to 0. Now, this answer would be rejected. Why? Because that would make x still equal to 0, and we just said x cannot be 0 over here. So, this is an improper answer. This is a rejected answer. Now, we factored, now we just have x minus 9 left. So, it's in our thing, in our factor, 2x, x minus 9. uh, we know that this is an invalid answer. So we're left with this x minus 9. So we do x minus 9 equal to 0, making x equal 9. That's the factoring method. Or what you can do, you can set this equal to 0, this whole thing equal to 0 as I did here, and then take 18 to the other side. You know, you take 18 to this side. Okay, so you'll have 2x squared equals 18x. You cancel the x's and then you divide by 2, so you'll have x equals 9. It's the same method, just that's the method I use. It depends on things. Okay, so we just have, I believe, 2 questions left and then we're almost done. Okay, write this expression as this one. Now what you do here, you have to make everything here have the same radical, have the same number in the radical. So in this case it was all 2 by trial and error. So 32 is 16 times 2, or 4 squared times 2. And then 128 is 64 times 2, sorry, so 8 squared times 2. And then 8 is 4 times 2, or 2 squared times 2. So when you take all of these out, you'll notice you'll only have radical 2 left, which is what we need. We need an equation, we need a result that all of them have the same number inside the radical. All of them. Okay, so then you just subtract. So 28 minus 24 is 4, plus 6 is 10, so 10 radical 2, and that's your answer. And now for the final one, it's the same concept. It's literally the same concept, except this time it's addition and subtraction, which I think is what we did here. So it's the same one. It's the same concept, but this time they don't want you to find the whole thing, since they gave you this. I did, just to check, you know. Ignore why this says 70. This should say 20. So this is wrong. This should say 20. Anyways, you take everything out, you'll be left with radical 3, and then you add, you'll get, you're supposed to get 20 radical 3. If you get 20, then your radical 3 answer has to be right, which means that this is your answer. And this is the end of the quiz. I know some of you won't be coming on tomorrow, but this exam will probably be retaken. I don't know when, I don't know what time. All I know is this exam will be retaken. So please focus on this quiz, especially since what I've noticed, this quiz is the one that most of you guys seems to be struggling with. This is the one that seems to be hard for most of you. If you guys are going tomorrow, please focus on this, as this is really important. This quiz, this is more important than the CE1, since this has contents from CE1 and more. But you please do CE1 too for the remarkable identities and the factoring. Okay, that's all from me for today. Tomorrow expect physics and maybe chemistry. I'm not guaranteeing chem. And on Wednesday, expect algebra. Okay, that's all from me. Good luck, guys. Happy studying, and hope you do well in your exams.